Hello everyone, welcome to Incredible Study. Today in this video we are going to discuss one new chapter, that is chemical bonding of class 11. So without getting delay, let's get started. Here under chemical bonding we discuss our first topic, that is electronic theory of valency. And electronic theory of valency, this theory was proposed by two scientists named G. and Lewis, that is Gilbert and Lewis, and W. Kossel, Walter Kossel, in 1916 AD. In order to explain how the formation of chemical bond takes place. And this theory is based on electronic structure of atom. So to understand this theory clearly, we have to go through basics. So here we go through our basics. Here you can see these are basics that we have to understand the theory very clearly. They are octet rule, first one, and second one valency. We understand octet rule and valency. First number, octet rule. We are going to understand octet rule. In common life, we see that common people want to be stable. It means common people want to be like hero. For example, Shah Rukh Khan, Salman Khan, and Tiger Shroff. These are examples. So as same in the chemistry, other elements want to be like inert gas elements because they are chemically stable, and the zero group elements are hero for other elements. So here we write zero group element. First one, helium, neon, argon, xenon, krypton, right? Krypton, xenon, and radon. They are zero group elements. Zero group elements. These elements are also known as noble gas or inert gas. So we consider, since they are chemically stable, we consider the hero element. We consider them hero element because they are hero for other elements. We know that they are stable. And we take one more example to understand very clearly. For example, in a society, suppose there are two persons, the person A and person B. Person A and person B. They are neighbors. Person A is poor and unstable, and person B is stable. It means stable means here he is well educated and financially free. He can sustain his life in happy, but the person A cannot. It means they are neighbors. So the person A wants to be like person B because here the person B is stable. He is well educated, well trained, he works in a good company, and he earns financial. It means he is financially free and can fulfill all needs and can sustain happy life. So here person A also wants to be like B. What person A thinks that I have to be well educated and I have to be financially free to be like person B. Okay, so all others as same like this, all other elements do same like this example, this two person. So other elements is A and these noble gas are person B, we suppose here, and other elements here wants to be like its neighboring stable element. Neighboring stable element means neighboring inert gas element, hero element, neighboring hero element, because we know that inert gas elements are stable. So here we write the statement for octet rule. Here all the elements have tendency to achieve tendency to achieve the nearest inert gas electronic configuration. Now we take example to understand the concept clearly. Here we take example first number, we take sodium element. We write configuration for this. The atomic number of sodium is 11. Here 11. We know atomic number for sodium is 11. So we write electronic configuration 1s2, 2s2, 2p6, 3s1. This is the electronic configuration for sodium metal. 6, 4, 10 and 1, 11. So what happens? This sodium wants to be like its nearest inert gas element. So the nearest inert gas element for sodium is neon, because the atomic number of neon is 10 and it's 11. So it is near to this neon. It wants to be like neon, and to be like neon it should lose one electron. It has to lose one electron. So it loses one electron here. So what happens? It loses one electron here and its configuration will be like neon. 2s2, 2p6. This is the configuration for neon also. And when this sodium loses one electron, then its configuration will be same as neon. It means it will be stable. Then the sodium will be stable. And here when it loses one electron, then it forms ion, that is cation. This is cation. It means electropositive element. They are known as electropositive element. When electron is loosed, then positive charge is assigned on the top of the metal. And we take one example, other example, we take chlorine, right? And we know the atomic number of chlorine is 17. We write electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5, right? 10 to 12, 5, 17. So here the atomic number of chlorine is 17 and it wants to like its nearest inert gas. So to be stable. Why they are doing like this? They are doing like this to be stable like these hero elements. So who is hero for chlorine here? Here argon is hero for chlorine element. So to be like argon, what it has to do? It has to take one electron in this orbital. So what it has to do? It has to add one electron over here. So when the one electron is added in chlorine atom, then it becomes like this. Its configuration will be like argon: 1s2, 2s2, 2p6, 3s2, 3p6. Here 5 and 1 added, then it becomes 6. And this is also electronic configuration for argon element, which is stable. And when the electron is added in any element, the negative sign is assigned on the top of it. So, and they are known as electronegative elements. So here we have taken two examples to understand clearly. We take one more example to understand more clearly. Here we take one example, that is we take phosphorus here, and we know the atomic number of phosphorus is 15. Here sodium, magnesium, aluminum, silicon and phosphorus. So here we write electronic configuration for phosphorus, that is 1s2, 2s2, 2p6, 3s2, 12, this is 10, 12 and 3. 3p, 3. It means what it does, it wants to be like its hero, and the hero for this element is here 15, and the hero for this element is argon. For this also argon is hero element. So to be like argon, what it has to do, it has to take 3 electron. It has to add 3 electron in its orbital. So here when the 3 electron is added in its subshell, then what happens? Here when the 3 electron is added, then it will be like argon. Its electronic configuration will be like this: 1s2 2s2 2p6 3s2 3p6. So this is also the electronic configuration for argon element, and they are stable. Since the phosphorus gains 3 electron, require 3 electron to be like argon, so here on phosphorus it takes here what it does, here 3 negative sign, right? So this is phosphorus ion, and the electronegative elements are known as anion and electropositive elements are known as cation. It means the elements having positive charge assigned on its top is known as cation. This is the cation of sodium, cation, and this is chlorine, and this is the anion, anion, anion of chlorine atom or chlorine element. So here we have understood octet rule very clearly with concept. So now we move to our next topic, that is valency. Here to understand valency we use this octet rule because we have concept here, and using concept we write valency. We write what is valency, the definition of valency. Here we know about valency. We all know valency is the number of electrons loosed, gained or shared during chemical combination or chemical reaction. The number of electrons gained or loosed or shared to attain stable electronic configuration. Electronic configuration is called its valency. So here the number of electrons gained, loosed, either gained or loosed or shared to attain stable electronic configuration is called its valency. So here the number of electron loosed or gained. So here this electron, the number of electron loosed here is sodium metal loses electron to attain stable electronic configuration. So here the number of electron loosed is 1. So the valency of sodium here, the valency of sodium is 1. And same in this chlorine, here chlorine atom require 1 electron to attain stable electronic configuration, to attain nearest stable electronic configuration. So here since 1 electron is added in chlorine, the valency of chlorine is 1 here. And in the case of phosphorus, here we see this requires 3 electrons to attain stable electronic configuration. So the valency of phosphorus is 3. Here we can say these are the valency for these elements. So here we have understood the concept of valency. The concept of valency. Now we move to our next topic under valency, that is variable valency. Here now we discuss variable valency under this valency topic. So the elements, some certain elements can have variable valency, can have more than one valency called variable valency. So here we take one example to understand clearly. We take iron. Iron has two valency, that is 2 and 3. Here we take Fe, that is iron, and its atomic number is 26. We write electronic configuration for iron, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3p6, 4s2, 3d6. Here 6 4 10 and 6 4 10 10 20 and 6 26. So this is the electronic configuration for Fe, that is iron, 26. And here iron has 26 valency, sorry, 2 valencies, that is 2 and 3. And the elements having variable valency are like this: iron, that is Fe, tin, copper, mercury, like this. Here Fe, tin, Fe means iron, here Sn means tin, Cu means copper, Hg means mercury, and blah blah. The reason behind having variable valency. So here we discuss reasons. Reason of variable valency. Here the main reason is the elements having incompletely filled d orbital have variable valency. Incompletely filled d orbital means this orbital is incompletely filled. It means the capacity of holding electron of d orbital is 10. It means it can hold 10 electrons, but it has incompletely filled d orbital. It has only 6 electrons. Therefore they have variable valency. Here we take, in case of iron, it has incompletely filled d orbital. So iron has 2 valencies, and here the lower valency of this element is assigned by OUS suffix, the suffix OUS. This is suffix. And higher valency of element is assigned by suffix IC. It means here, if the here we know iron has 2 valency, that is 2 and 3. So for valency 2, iron has, it means it will be like this: ferrous, ROUS, OUS suffix. And for this higher valency, that is 3, we use here write IC suffix. This is, that is, we are discussing here reason. It means here in case of iron we see incompletely filled d orbital. So in case of ferrous, what happens? In case of ferrous, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. What happens? Here 4s2, it just loses 2 electrons, because this iron is metal and it loses 2 electrons. Therefore it has valency 2. And in case of ferric, what happens? Here we write electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p, here 3p6 and 3d5. And this further loses 1 electron to achieve stable electronic configuration, to be stable, because there is one rule, that is half filled and full filled are more stable than others. So here, since the full capacity of orbital d of holding the electron is 10, it can hold 10 electron, but here is 5, it means half, it is half filled. So this is more stable. So to be stable, it loses further 1 more electron, and its valency will be 3. So here this is a reason for having variable valency. Now we discuss valence electron and valence shell under this topic. Valence electron, valence electron and valence shell. Valence electron and valence shell. So the electrons in the outermost shell of an atom is called valence electron. In the outermost shell. Outermost shell means valence shell. Here the definition of valence shell is the outermost shell of an element or of an atom is called valence shell, and here the electrons revolving in the outermost shell is called valence electron. And now we discuss the electronic theory of valency. Here now we discuss electronic theory of valency. Here we have written the postulates of electronic theory of valency. In first number, the outermost orbit of an atom is called valence shell and corresponding electrons are known as valence electron. It means I have told that if this is an atom, then the outermost shell, you can see the outermost orbit, this is outermost orbit of an atom is called valence shell. It is called valence shell, and the electron in this outermost shell is known as valence electron. Only valence electrons take part in the formation of chemical bonds. Here we will discuss this term chemical bond in detail, because this is our chapter topic name, chemical bonding. So only this valence electron takes part in chemical bond. It takes part in chemical reaction. Here second number point, the capacity of an atom to take part in chemical combination is determined by the number of valence electron. Here the same thing. When the atom takes part in chemical combination, then this is only determined by the valence electron present in its valence shell. Here capacity of an atom to take part in chemical combination is only determined by the number of valence electron. Third number, atoms with 8 electrons in their valence shell are most stable except helium. Here except helium, because except here helium has 2 electrons in its valence shell and it is stable. Most other atoms to become stable try to acquire octet state by losing, gaining or sharing of electron with combining atom. It means, as I have told, that to attain the octet state all the elements wants to be like hero element, that is zero group element. So they either lose, either gain or share their electron with the combining atom, so that can be stable. Therefore this tendency is cause of chemical combination. This is why the chemical combination is possible, because all the elements wants to be stable, and for stability they fight with each other, and this cause chemical combination, chemical reaction. Fourth number point, during chemical combination atoms adjust their nearest inert gas electronic configuration by losing or gaining of electron or by mutual sharing of electron. Here this means during chemical combination either all other elements, the atom of other elements want to be like the atom of nearest inert gas element. It means they want to make its configuration like the nearest inert gas electronic configuration. Either it can be by losing, by gaining of electron, or by sharing of electron, by mutual sharing of electron. They share their electron mutually. It means this term we will discuss in bond. Okay. So now here fifth number, the number of electrons lost, gained or shared by an atom to acquire the inert gas configuration is the valency of that element. Here, either as I have told that here we have understood about valency. What is valency? So here valency is the number of electron either gained or lost or shared to achieve stable electronic configuration. That is called valency. 6 number, chemical bond will form only if there is an overall decrease in the energy due to the redistribution of electron. Here, when the electrons are redistributed and if their energy decreases, then only chemical bond get formed. So here chemical bond we will discuss in the next part of this video. We will be dealing this chemical bonding topic in various parts. In the playlist of chemical bonding topic you will find video soon. So for this video only this much, and I will catch you up in the next one.